Hello, ladies and gentlemen. Welcome back to the circulatory system. We are once again going to be talking about the heart, specifically today how the heart is able to beat, which is actually pretty cool. What you're seeing in front of you are living cells that were created, as it says, at the medical center. These are independent heart cells that you will be able to see beating without being inside a heart. Okay, you can see that they beat independently from the heart. When they touch, they actually are able to coordinate their beat so that they beat together in a set pattern. They often use this tissue to see how heart cells will respond to certain medications and things. They also are now using them to grow patches so that if a human heart was damaged or part of it died, they would actually be able to use the person's own cells to grow a patch of heart tissue that would be able to repair whatever the tissue damage was. Okay, now if you look at this picture, you should already know most of the structures. However, today we are going to talk about what you see that is in yellow. Okay, starting right here, this is referred to as the sinoatrial node. It is what is sometimes called the pacemaker of the heart, and it actually generates the electric current that the heart will be controlled by. Now, it sends the electric current out into fibers to the left atrium and down through the right atrium, and this causes the atria to contract at pretty much the same time. You then have it go to this right here, the atrioventricular node between the atrium and the ventricle, and it brings the current down through this, which is called the bundle of His, even though it's spelled H-I-S. The electrical current will then travel down through these fibers and up into what are known as Purkinje fibers that are in the muscles of the the ventricles right through here, and they will cause the ventricles to contract at about the same time. Okay, so you end up with part of the beat of the atria, part of the beat of the ventricles here. And that's actually why you have that dun sound, is the atria will contract and the bicuspid and tricuspid valves will close. That's the first part you hear. And then the ventricles will contract with the valves to the aorta and the pulmonary arteries closing, and that's the second part you hear. So you hear lub, dub for the two parts. Okay. For this animation, just primarily watch the part about how the heart has the electrical signal travel through. Do not worry about the different waves of the signal itself. Just be aware that that's where they're coming from, is the electrical currents.
Of the heart. It initiates all heartbeat and determines heart rate. Electrical impulses from the SA node spread throughout both atria and stimulate them to contract. The atrioventricular node, or AV node, located on the other side of the right atrium near the AV valve. The AV node serves as electrical gateway to the ventricles. It delays the passage of electrical impulses to the ventricles. This delay is to ensure that the atria have ejected all the blood into the ventricles before the ventricles contract. The AV node receives signals from the SA node and passes them onto the atrioventricular bundle, AV bundle, or bundle of His. This bundle is then divided into right and left bundle branches, which conduct the impulses toward the apex of the heart. The signals are then passed onto Purkinje fibers, turning upward and spreading throughout the ventricular myocardium. Electrical activities of the heart can be recorded in the form of electrocardiogram, ECG, or EKG. An ECG is a composite recording of all the action potentials produced by the nodes and the cells of the myocardium. Each wave or segment of the ECG corresponds to a certain event of the cardiac electrical cycle. When the atria are full of blood, the SA node fires, electrical signals spread throughout the atria and cause them to depolarize. This is represented by the P wave on the ECG. Atrial contraction, or atrial systole, starts about 100 milliseconds after the P wave begins. The PQ segment represents the time the signals travel from the SA node to the AV node. The QRS complex marks the firing of the AV node and represents ventricular depolarization. Q wave corresponds to depolarization of the interventricular septum. R wave is produced by depolarization of the main mass of the ventricles. S wave represents the last phase of ventricular depolarization at the base of the heart. Atrial repolarization also occurs during this time, but the signal is obscured by the large QRS complex. The ST segment reflects the plateau in the myocardial action potential. This is when the ventricles contract and pump blood. The T wave represents ventricular repolarization immediately before ventricular relaxation, or ventricular diastole. The cycle repeats itself with every heartbeat.
Okay, so you could see that the heartbeat electrical current is what actually creates the EKG, and that's just the pattern of the electricity traveling through the heart. Now, this is an actual heart. This is how they keep a heart alive from a donor until it gets to the recipient, and they keep it alive. They will pump blood through the heart and keep it oxygenated and keep it living. Now, your heart will not move as much as this one because your heart has things holding it in place. But what I wanted you to see is the way that it contracts. You have the upper atria right through here that contract first, and then the ventricles down here. You can see it's taking turns beating. You have the top and then the bottom. You don't have it just beating all at once. You have this rhythm.